everyone. As you probably know, I make quite a few PCBs now, but up to this point I was outsourcing the assembly of these PCBs to different companies around the world because of, well, you can see the elephant in the room right now. This was simply not feasible, but I always wanted to move production in-house. I always wanted to assemble PCBs myself. So recently I've pulled the trigger on a bunch of equipment to be able to do this myself in-house. And yeah, I think this will be a pretty interesting topic to cover on YouTube. So this will be a series of a few videos, but in this video I want to start with the new pick and place machine I just got, Trontol A58, and also some of the other equipment I had to buy to make this work. So yeah, let's get to it. But before that, thanks to PCBWay for sponsoring this video. PCBWay offers cheap, fast and high quality PCB prototyping services. As someone who used their PCB services in the past for multiple projects on this channel, I can recommend them to anyone who's looking for a PCB manufacturer for their next project. They also offer other types of prototyping services like 3D printing, including MJF, SLA, other types of 3D printing services, and other prototyping services like CNC machining, injection molding, and laser cutting. For more information about their PCB and other prototyping services, click the link in the description below. So here is the pick and place machine I picked for this job. It's Tronstol A58. This is a Chinese pick and place machine that's more like prosumer than industrial, because industrial machines are like $500,000 or stuff like that. Plus they wouldn't really fit through the store. And yeah, this is in the middle of my living room. I'm hoping to fix this pretty soon, but for now it is what it is. But yeah, so this is more of a prosumer machine. It is better than the desktop machines, and I will talk about why I didn't go with those machines and instead went with this fairly large floor standing machine later. This is a 58, that's where the name comes from, 58 feeder machine, though I'll get to the feeders in a bit as well. It's not exactly 58, with 4 heads. They claim it can place components as small as 01, 005. I kind of doubt that, but 04 or 02 should be fairly safe. This, you can see the gantry of this here. It's a Cartesian style gantry. You might be familiar with this sort of layout on 3D printers. And you can see the motion stuff here. So this is using ball screws for motion of both axes, X and Y. So yeah, 2 ball screws here and here for the Y and 1 for the X. There are 3 240 volt, and yes, I'm in the US, I'll get to how that works later. 240 volt, 400 watt servos here, here. So it's 1.2 kilowatts technically, and you do need that because this needs to move a fairly heavy mass. This tool head, people call stealth burner heavy. Well, yeah, there's quite a bit more going on the tool head. I'll show that more closely later. It needs to move that fast, accurately, and yeah, it's very heavy, so you do need a setup like that, and the ball screws will help with that. There are also some encoder things on the gantries which I don't exactly know where they are. That is for positional accuracy, because, well, you do need to place the components very precisely on the PCBs. So yeah, that is something you need as well. And because of all that mass and speed and all that, there are obviously linear rails, and these are very chunky linear rails. My finger for reference, I guess. I don't have a banana. Now we're on the other side of the machine, and you can see there are 4 heads on this machine, 4 pick and place heads, and currently only one of them has a nozzle populated. That's a CN040, which is used for 04, 02 passives. The other 3 don't have nozzles right now, so that's why they're lowered. And you can see this rectangular structure around the nozzles. So that's a 3D scanner, or they call it a camera, but I don't think that's the actual technology for that. And that's used to scan the component the nozzle picks up and make sure that A, it is actually picked up, and B, figure out its exact position, so that it can move the head to the correct spot on the PCB and place it at the exact right spot on the PCB, instead of placing it rotated or slightly off center or whatever, because each pick isn't going to be perfectly accurate. So you do need sensors for that to do that reliably. If you're using a machine for production, which obviously my goal with this machine is that, There's also another camera on the head. That's a mark camera, and that's a proper camera, and that's for identifying fiducials. And yeah, you can also see that on the screen when the machine is on, so that you can align things. And yeah, that camera is also part of the vision system. And there's another camera here, and this is for identifying big ICs that you'd put on the IC tray. Like for example, if you put an STM32 MCU or something on here, and you need to place that on the PCB, while the scanner thing I showed on the toolhead won't be able to actually scan that. So the head would grab that, bring it over here, and this camera would be used to figure out its exact position and its exact rotation, so then the head can move onto the PCB and place it correctly. So this machine uses 6 cameras/sensors for that. It's a fairly advanced vision system compared to a lot of desktop machines, and that was part of the reason why I went with something like this. So the machine has slots for 29 feeder banks on both sides of the machine. So it starts from 1 and goes up to 29. That one is covered, but maybe you can see that. So machine supports up to 29 theoretically feeders on both sides, but in practice you'll notice that this camera thing is blocking 5 of them. So it actually supports 24 on this side. So the machine is called Trontol A58. 58 comes from the feeder number it supports, but in reality it's actually 53. And if you're using anything wider than 8mm reel/tape, then you'll need a chunkier feeder, and those guys take up more than one slot. So in practice, with a more typical distribution of components, you'd probably only be able to fit, I don't know, 40 feeders or something, maybe 45. Depends on how many 402 or small passives you have versus bigger chips, but yeah, I mean, that's still pretty reasonable. I have one board that is currently in development that will need more than that. In fact, it will basically need 2 full loads of this machine to assemble that board, and you can actually get another machine next to it, and then there is a communication interface somewhere. I haven't figured out how that works, because I'm not going to be able to buy another one of these guys for a while, to say the least. But yeah, you can actually set up a proper production line with multiple of these machines, and yeah, they can communicate with each other. So that basically you can double your feeder capacity by just buying another machine, but that's not something I'm going to be able to do. So I do have one board that I'll have to run through this machine twice, but for most boards, that 40 something capacity should be enough in theory. There is also an IC tray here, obviously, for bigger ICs, like, as I said, STM32 MCUs or whatever. Some of them you can get on really wide reels if you prefer, but vast majority of cases you'll get them on trays. So you put the tray on there, and the machine uses its vision magic to figure it out and place it accurately on the board. This machine also has a 3-section conveyor system in it, so that's for feeding the PCBs in a more like, it's more useful for assembly lines, I suppose. But yeah, you can see the 3-section track. One ends here, there's another one, and there is another one. So in a production line, the next PCB would come here, wait here, and then the PCB here would be being assembled at that point, and once it's done, it would spit it out here and then bring in the next PCB and so on. But even when you're not using this in a production line, which I might eventually be able to do, but it's not going to be anytime soon, I think it's still pretty nice to have that feature, because I can just put in the next PCB that I want to assemble here while this machine is doing its thing, and then after it's done, I can just grab the next PCB here when I'm available, without while the machine brings in the next one and starts assembling it, so I wouldn't lose any time. With the way I'm going to do the reflow for a while, which is a toaster oven, yeah, the board might need to sit here for a while, so that is a time-saving thing. So that is also definitely nice. So yeah, you can see the 3-section track, and you can also see lead screws on both sides. These are not bolt screws, these are lead screws, but they're also on linear rails. That's for adjusting the width of the conveyor, because each panel of PCBs will be a different size. So this machine supports different sizes of panels. I think it's currently set to 100 millimeter width, but it supports more than that. So when the PCB comes here, there's a little stopper thing, which is actually just a M3 standoff as far as I can tell, that raises here with a solenoid probably. And once the PCB hits that, these solenoids raise the PCB and lock it in place, and then the machine can do its pick and place magic and yeah, do its thing. And once it's done, it lowers the PCB, moves it out of the way, and brings in the next one, and so on. So the motion for that is done by, as far as I can tell, NEMA 17 stepper motors. And yeah, that's also what's used for the lead screws. There are a lot of stepper motors on this machine. For example, on the tool head, obviously the heads need to move up and down, and for that you can also see some stepper motors. So there are 4 stepper motors on this tool head, and the thing itself is metal as well. And yeah, there's a bunch of PCBs in there as well. So yeah, this tool head is going to weigh a lot. And if you're wondering how the machine is picking up the components, you can see these clear tubes here. So it uses vacuum. So this is, for example, a nozzle. It plugs in like that into the head, and yeah, there's a hole in there. There'd be a chip in here, for example, and then the machine brings the nozzle on top of that, sucks some air out of it, it vacuums it up, and then moves it and then places it on the PCB. That's how that works. I'm mostly showing this because, well, Vorons, but if you're familiar with Voron 3D printers, this is what we used to use for bed leveling. It's on Omron inductive probe. And yeah, this machine has 2 of those. And again, I'm only showing this because of the, yeah, because Vorons also use that. But yeah, it's just a door sensor. So there's a metal strip here. When you close the door, it detects that. And yeah, it runs the machine, because otherwise it's not going to run the machine for obvious, hopefully, safety reasons. Yeah, so far I haven't done much with this machine yet. I did a motion test, which you can see on the screen right now. It just moves the gantry on X and Y, and then X and Y. And yeah, I don't know if that's the maximum speed this machine can reach or not, but that was just one of the test commands I could find in the machine. So I ran through that. And I also assembled, there was a test PCB that was included with the machine, and I also assembled that. But the test PCB that was included with the machine, it was a panel of 4 PCBs, and the size of the panel was 100 by 200 millimeters. There was a file for that included in the machine as well, for the pick and place, you know, the coordinates. But that one was configured for 200 by 200, not 100 by 200. So I think that's what went wrong with the second attempt, but you can see the first attempt right now on the screen. And yeah, I just tried to place a bunch of 0402 resistors, and yeah, that was a problem. That was a mess. And I think what went wrong there is the pick and place speeds. I think the defaults were a bit too fast, so I lowered them for the second attempt, and it placed them in a perfect circle. It's just a bit offset, and the machine also had a hard time identifying fiducials and stuff like that, which it's trying to do based on the data that's on the file that's included in the on the machine. So I bet they included the wrong file or something like that, because again, the dimensions of the board are incorrect. But based on the fact that it placed the resistors in a perfect circle, and if I shifted those resistors slightly, it would be perfectly on the pads. I think the machine did a good job. I think it's just a problem with the files that were included with the machine. And of course, I ended up opening a feeder just to see how it works. And yeah, there is a lot going on in here. So this is the cable that connects to the pick and place machine. There are 4 wires inside there, and they come out, if the camera focuses here. Yeah, I don't think you're going to be able to see much of it, but the 2 power wires are going to this board here, and there are 2 more wires going to somewhere. I'm not going to be able to completely take this apart, but yeah, anyway, those two wires are for power. That's 24-volt power. There's a buck converter here and an LDO here, so it drops it down to who knows what voltage, the buck converter, and LDO probably does 3.3 volts. and that's because there is a STM32 MCU on here. So these two square chips next to the STM32 MCU, those look like stepper drivers, and these big resistors being the sense resistors for the stepper driver. And you can see the 4-wire JST XH connectors there for those. So one of those goes in here, and I can't trace the wire completely, but I'm pretty sure it goes around here. And then there's another stepper motor in here, and that's the one driving the basically extruder gear, but for peeling the film, this thing. So 2 stepper motors, and then there are 3 connectors here. There's this guy, let's see what it's called, tension. There is one for run, and there is one called 0P. Starting with the tension, the wires for this go here, and that's the arm that detects tension on the film. So that naming for that makes perfect sense. That's the tension sensor. And then we have 2 more sensors here, and they go somewhere in there. I'll try to flip this over and see what we can find there. For now, let's just say that the 2 sensors here and the stepper cable go there, and we'll take a look in a second. And then we have this small connector, which doesn't really have a label, but because of how many wires there are on this cable, I'm going to guess that that's the control thing here. There's a 7-segment display and 5 buttons, and I'm pretty sure that's for that. So yeah, quite a bit going on this thing. Let's flip it over and try to see if I can find the wires going there. Yeah, it's supposed to be a stepper, 2 sensors or whatever cables from here, and the 2 wires coming from the pick and place machine, some sort of, you know, control signal. So let's take a look. So I flipped the thing over and removed the cover here, and well, that looks pretty interesting, but let's start with the boring bit. Let's start with this tiny PCB in here. So that's just a PCB with 2 connectors. This connector comes from the cable coming from the pick and place machine, and this cable is going to the controller in here. That's one of those signal cables. So all this is an optocoupler for additional, you know, safety. Just so if there's a problem with the signal, it doesn't fry the feeder, sort of thing. The other signal cable comes here, through here, onto here, and goes to this thing here. So that's encoder, and that's for position, identifying the position of the feeder gear in here. So yeah, there are some notches on that gear, on that middle metal bit. Camera's really having a hard time focusing today. There we go. And that's how it knows where the gear that drives the reel is. So this is the actual drive of the reel, and the peel that also has a stepper motor driving it, and this is the stepper motor doing the job. That's a NEMA 17 with a teeny tiny gear on top that goes into this big brass gear, and then goes through several gears in here, which I'm not going to take apart, because if I do, I'm sure I'm going to fuck that up. And that eventually drives the reel, or the strip coming from the reel. So yeah, that's how this works. So let's take a look at the insides of an 8mm one as well. This is one side. I'll flip it over just like I did earlier. One thing that's immediately obvious to me though is this is a NEMA 17 motor driving the peel, this clear film on the strip. And that is interesting because that's not how the other one works. You can see a pretty complex set of gears in here to just drive this, basically what we have in 3D printer extruders to pull the film. But yeah, it's a NEMA 17 stepper this time, a bigger one. Fucking cat. Anyway, and then we have another NEMA 17 here going through the same sort of gear system. This might be more or less, or maybe even pretty much identical to the setup on the bigger feeder. But yeah, it's just slightly differently arranged, and it is driving the gear. And this is the encoder, and there is the encoder PCB with its cable, and they're all running into here, which is on the other side, which I'll open, and cables from this also go here. So that's where the controller is, obviously. And yep, sure enough, there is the PCB in here, but it's a different PCB than the ones we found on the other feeders, the bigger ones. This is an 8mm feeder. The other one was either 12 or 16. 12 and 16, they're both constructed identically. Only difference seems to be the water opener bit here, which is based on the width of the strip. So yeah, this is different, this is thinner, and they use a different PCB on here. Pretty sure it's the same MCU STM32F0 based on its size and the fact that the other guy was using that. Pretty sure it's more or less, if not the exact schematic on there, but it's just a different layout, and I guess this layout made more sense for this for this feeder, I guess. Yeah, it's basically the same thing. So really the main difference in terms of how this works that I've identified is the NEMA 17 stepper in here. And I'm pretty sure that's because this thing is very thin, like this is the head of a Phillips 1 screwdriver, and it's thicker, quite a bit thicker, maybe double the thickness of this thing. And yeah, it needs to be very narrow. The bigger feeders were thicker, so my guess is they couldn't fit a stepper that was smaller without making it thicker, so they used a bigger stepper for the peel drive. But apart from that, it appears to be more or less exactly the same. But yeah, I'm still glad I tore this apart, because yeah, I am curious about this sort of stuff. So pretty cool to see how this stuff works under the hood, and yeah, hopefully they'll work well feeding the reels. We'll see, I guess. So just a quick walkthrough of the stuff that's attached to the machine. So this is the side with the camera and the feeders. I have the door closed this time, but by the way, this is just protective film that I couldn't remove. That's not damage. So this is where you have one of your electronics access panels behind here. In here you find a Linux PC Intel Atom based thing. And you also find the vacuum pumps for the 4 pick and place heads. And you don't need an external air supply for this machine to work if you're using electric feeders like I am. But if you're using pneumatic feeders, you do need an external compressor for them to work. And that you connect here. And obviously there are some conditions you have to meet in terms of the quality of the air and stuff like that. But yeah, again, I'm just using electric feeders. That's why there are these buttons on here, and that's why there are stepper motors in here. If you're using a pneumatic feeder, then all that is done mechanically without any electrical stuff in there. So it literally just sends compressed air to the feeder, and the feeder advances. But for O4, O2 and tiny components like that, it is better to use electric feeders. And yeah, even for larger ones, I just didn't want to get a compressor, so I went with all electric feeders for the setup. You can also find the Ethernet connector here and the power input. I'm not sure if the Ethernet one is actually Ethernet or if it's for the daisy chaining of these machines. I think it might be for that. But yeah, the power input is literally just a power input. Moving on to this side, there is the like knee-high computer tray. I don't think it's really designed for the Western market, but whatever, it works. But that's why this guy is here, so that I can actually use the thing. I wish this was a touch display, because if it was a touch screen, I could just, touch while I'm standing up. I just angle it like so, and just touch it. And on here, you can find some of the stuff to operate the machine. So this is the power switch. It's a latching switch. This is the emergency stop. There's a start pause button here, and then there's a button here for turning on or off the LEDs inside the machine, so you can see inside a bit more clearly. And this is the cables for my microphone. And down here is the other electronics chamber, and there's quite a bit going on inside there. So in the electronics chamber, first of all, what we find is this power transformer boosting the voltage from 110 volts to 220 volts. Remember when I said the servos were running at 220 volts? Well, this is what makes that work. So it's boosting the voltage to what the rest of the world uses, really. And then we have 2 power supplies here. for some of the other stuff, and then you see that there's a ribbon cable, and only a ribbon cable connected to this. This is going to the main controller here, so it's getting connected here, and the power that's boosted is also getting connected here, and the mains power connected here is flowing through that ribbon cable into those power supplies. Now, I'm not really a big fan of a lot of the mains setup in this electronics chamber, and that includes this as well. Like, this is really not an amazing way of doing this, but I suppose it works. And in general, this PCB, even though it handles mains power, is not really designed with all the appropriate safeties for handling mains power. For example, there are no cutouts between these mains traces. If you open a power supply, for example, you'll see that there are cutouts between power traces, and that's there for a reason. I feel like they wired this in a way that they thought it would be fine, it would work, but it is not up to proper code. So that's the main thing I dislike about the electronics chamber of this thing. And you can see that the power cables, the live wire is also daisy chained like this, and yeah, in here, for example, you can see that one isn't perfectly in the screw terminal, and in general these are ferrules going into the screw terminals. You should use spade or ring terminals, not ferrules, if you're using this type of screw terminal. So yeah, not amazing, but yeah, I mean, I guess it works. And yeah, there isn't a whole lot going on this board, as you can see, so there's some buck converters and stuff like that, but as you can see, vast majority of stuff is just connected with Ethernet cables to this PCB. Now, those are not actually wired for Ethernet. The whole machine has who knows how many CAN bus nodes, so this printer is using CAN bus, and yeah, all these connections are CAN bus connections going to various different PCBs on the machine. And there are a few more up here as well, and then a few different types of connectors like some JST XHs. There's also a power switch here, that's for the light. So in the electronics chamber, because it's in the electronics chamber, there is actually a light switch here which you can press, which will turn on the LEDs in the electronics chamber, which is a nice touch. It's definitely nice to see, because that helps you see what's going on in the electronics chamber, which is otherwise pretty difficult, since the whole electronics chamber is inset and in a black enclosure. So that's what this switch is. I don't know what this switch is, but there is a light 2 connector here, so probably another light switch, but nothing is connected there, and I haven't actually pressed that button, so I don't know for sure. But also in the electronics chamber, you'll notice that there are 3 mains connectors here, and that's separate to this one, so 3 more. And there are also another ribbon cable connected here going down, and these cables are also going down, so they're going to the PLCs here. So these are what are controlling the servo motors. As I showed you earlier, there are 2 servos on the Y, so Y1 and Y2, and 1 on the X, and this is what's controlling the servos. And you can see up here they're coming from the PCB getting connected into the PLC. So those servos are running 220 volts or thereabouts mains power through these things. There is a fan down here which is connected to the PCB here, and yeah, there's some limit switch and whatnot connectors as well. But yeah, man, this is pretty much a dumb board, because as I said earlier, the main control is through the industrial computer that's built into this machine, which is running Linux Mint and their custom software. If I had to guess, it's probably built on Linux CNC to some extent, but yeah, there's a Intel Atom based thing in here. Nothing fancy, but that's what's running the actual control. So the controller board in here doesn't have to do much. It's just basically an MCU, CAN transceiver, and the miscellaneous stuff supporting it. That's basically it. And the motor control, as I said, is done using these PLCs, and stepper motor control is probably on separate PCBs with separate stepper motor drivers, because I'm not seeing anything stepper motor drive related on this PCB. And I also want to talk about some of the rest of the equipment I'll need to assemble PCBs. As I said, the pick and place picks and places the components on the PCB, but before it does that, the PCB needs to have solder paste applied to it. So this stuff, I got this tub of chip quick solder paste way back when I first started assembling Nevermore sensor PCBs myself, and since then I had to move that to China as well, because hand placing those components was A, really time consuming, and B, I was awful at it, but the pick and place machine should be able to do that no problem, so I'll move that back in-house. But yeah, with the pick and place machine and all that, with me assembling more complex boards, I'll need a proper stencil printer. So this is the stencil printer I got. This is a Mancorp something or another. I'll put the part number on the screen. This is a model that's no longer being made, and it hasn't been made in a long time, but I managed to pick this up on eBay for pretty cheap, like really cheap. So yeah, that worked out, and it also included the squeegee as well, which this also feels like a pretty decent quality one. But yeah, the way this works is you have a stencil like this. So this thing is called a stencil printer, but it's not actually printing a stencil, it's printing solder paste through a stencil. So I don't know why it's called that, but it is. So yeah, you have a stencil like this, and I have a stencil for a board that's currently in development on there. You put the board on here, and there are these pegs on here, which in this model are magnetically placed in place, and they have these inserts which with the appropriate size peg that go into the PCB. So yeah, you place the board on here, and then you close the top, you put a bunch of solder paste on here, a decent amount, and then you grab your squeegee and just apply it to the PCB. And if you did it right, the solder paste, you'll have the right amount of solder paste applied to the PCB. I think this was a few $100, which is again very cheap for what it is. It is not perfect. This screw, I don't know if you can see on video, but this screw is bent, and that makes adjustments a little bit difficult. So what these do is, you can see the gap here, and you can also see the springs that are pulling this here. So yeah, what this does is, as you tighten this, it pushes the PCB this way, and this does the same as well. And the reason you have two on this side is so you can do adjustments like this, just to get it perfect, and you only have one knob on this side for pushing it like so. And all that is to make sure that you have all the holes lined properly on the PCB, because you can have really tiny holes, for example for 0402s, or you know, these QFN packages, for example. You can have really tiny holes, so you really need them to be pretty much perfectly printed. So that's what this guy is for. And yeah, I mean, it feels like a pretty decent stencil printer. So yeah, I'll, I guess, have more to say about this once I actually use it a bit. I printed, I think, 2 PCBs so far with this, and it went all right, but that's not enough experience to properly judge the quality of this thing, so we will see. And after the parts are placed on the PCB, I also have to obviously solder them, and that happens in this reflow oven. This is not a proper reflow oven, it is just a toaster oven, and I actually made a video about this, I think it was a couple of years ago, when I first built this thing. So this is a Breville, I think, toaster oven, and it has a bunch of electronics applied to it, as you can see. So that's a Controlia 3 controller by Wizu, and a bunch of extra heating elements and stuff like that as well inside. And yeah, this makes it a pretty decent reflow oven, which is used to activate solder paste to solder the components on the PCB, and that's obviously only for through hole stuff. So after this step, the next step is to do the good old soldering iron stuff. So I might make a separate video about this down the line, but I have this Pace ADS 200 plus soldering iron, so just use that to solder the through hole stuff. And yeah, that's the PCB assembly process. I have plans for improving some of these things. Like for the stencil printer, I intend to get an automatic stencil printer down the line. And for the hand soldering of the through hole stuff, which is mostly just connectors, I eventually intend to get a wave soldering machine, and that will make things fucking gimbal. Anyway, that will make it a lot easier. So yeah, there will be a wave soldering machine down the line as well. I just don't really know when. So that is part of the plan as well. But yeah, for now, this is the setup. So what you've seen so far was mostly recorded a few weeks ago, and since then I've managed to assemble a board, and yeah, there was a lot of lessons learned in this experience. Just a reminder that I don't really know what I'm doing, and this is my first pick and place machine. I've assembled a few boards with surface mount components, actually a few hundred of them, Nevermore PCBs, before I started outsourcing that again. But this is my first pick and place machine, and in general I don't have much experience assembling surface mount stuff. So yeah, there was definitely a lot of lessons learned with this experience. I assembled the board that I was talking about earlier in the video, the board that I will have to run through the machine twice, which is a board that's currently in development, and I'm hoping to share a bit more about that in about a month. But yeah, that board is a 6-layer PCB with thick power planes and a bunch of expensive chips. So it was actually not a great PCB to start with in terms of learning how to do this, but it was the only board I had on hand that I could assemble, so I started with that. So I've identified 3 problems with my setup so far that I need to work on fixing. The first one was I noticed some of the chips were placed a bit off center on the PCB, like they weren't placed perfectly. And digging more into that, I finally managed to catch what I believe to be the root cause of what's going on camera. So this is an SOIC8 package. That's a fairly large chip, which is probably the only reason I was able to catch it on camera, because smaller things you wouldn't really be able to see. But yeah, you can see that the machine picks up the chip, brings it over the PCB, places it on the PCB, and then proceeds to lift it and drop it on the PCB. So what's going on there is, as I said, the machine uses vacuum to pick up the chip, but it doesn't let the air back in fast enough for it to actually stay on the PCB. So it lifts the head a bit too fast, and yeah, that results in the chip being raised and then dropped on the PCB. I'm sure there is a way to tweak this, and I will dig into this. But yeah, the software is not amazing. Like it's a Chinese machine. It is in English, but the translations aren't amazing. So it is a little difficult to figure out, but I'm sure there is a way to tune this, and I will figure it out. And I believe that might explain what's going on with some of those chips. Another potential thing I have in mind is it might not be placing the chips. It might not be pushing the chips on the board as much as it should onto the solder paste to rely on its tackiness to hold the chips in place. But speaking of the solder paste's tackiness, as I said, the idea with this PCB was to run the PCB through the machine twice, and that's just not going to work. And the reason for that is, well, there are 2 reasons. It takes about 3 hours to swap the feeders from the setup that I ran the board through the machine the first time to the second setup, and in that time the boards have to sit somewhere in the room exposed to room temperatures and air. And as I said, there are 2 problems with that. One of them is it's actually pretty easy to move chips on the board, like a bump or air or cat, whatever, might end up just pushing the chips around, and it is very easy for the chips to just shift on the PCB, which is obviously not going to work because you do need them to stay in the correct spot. And the second and the bigger issue, and as I said, this is to do with the solder paste's tackiness. Solder paste doesn't like being exposed to air, and most solder paste, though I am using room temperature stable one, but most solder paste aren't. Most solder paste also don't like room temperatures. So what that means is it dries the solder paste out, which is the flux that's in the solder paste, because solder paste is solder that is suspended in flux. So you're drying the flux out, which can have implications for the reflow process, but the bigger problem I've noticed is to do with its tackiness. As I said, that tackiness is what's keeping the chips in place on the board, and if it's exposed to air like that, it loses some of that tackiness, which means when you place a new chip on the board, it's less likely to stay in place. And yeah, that is definitely a big problem. So running the board through the machine twice while technically it should work. Because of the solder paste, that's not going to work. So what I need to do is optimize this as much as I can, put as many feeders on the machine as I can, and then hand place the rest of them myself for the production runs, which is not ideal because I don't want to get into too much into this, but I have a neurological thing. My hands aren't great, but it is what it is. I will have to hand place, you know, obviously ideally as few chips as possible, but a decent number of chips nonetheless, myself. And yeah, that is definitely a very important lesson learned with this experience. I'm not going to be able to get a second machine anytime soon, so I will have to consider this when I'm designing boards. So far my focus was mostly on optimizing the BOM in a way that would cost me the least to have someone else assemble these, but now my focus has to be my own setup with my own equipment. And the third lesson learned was to do with that reflow oven. So as you've seen, I'm using a reasonably professional stencil printer and a reasonable pick and place machine and a toy reflow oven. And yeah, you can see where that is going. That reflow oven is not sufficient. So as I said, I've assembled a few hundred of those Nevermore sensor PCBs, and that reflow oven did a perfect job with those. The problems I had with those boards were down to me printing the solder paste through the stencil or hand placing the components. The oven always did a good job with those. But as I said, this PCB is far more complex. It's a 6-layer PCB with power planes, and yeah, that means there's a lot of thermal mass on this board that the oven needs to heat up and cool down very quickly. And that oven just cannot keep up with all that. And the reason it can't keep up with all that is because it has a single chamber. Like, it doesn't take the board from chamber A and move it to chamber B and then chamber C and so on. It's a single chamber that is heating up and cooling down, rather than moving the board from a preheated chamber A to a preheated chamber B and C and so on, which is how real reflow ovens in proper factories work. And there are reasons for that. It's mostly to do with the fact that each board is different and the amount of heat each board absorbs is different. So the chamber needs to be warm enough to heat the board before it starts heating further or cooling down. And yeah, the heaters on a toaster oven just cannot keep up with that. So yeah, it's fine for most boards, but for more complex, more advanced boards like this, it's just not going to work. So I need a proper-ish reflow oven, which I've already ordered and I'm waiting for the delivery of. So that's another thing I need to improve with my setup. And as I said, eventually I have other things I want to add to my setups as well, like the wave soldering machine I already mentioned and the automatic stencil printer. I also want to get a automatic optical inspection machine and possibly even an X-ray machine, especially if I want to delve into QFNs and BGAs and stuff like that. But yeah, all that will be way down the line. I don't even have room to put this in. And my home is very cramped. This is a 1-bedroom apartment. The bedroom is the workshop. So I already sleep in the living room, and now the living room also has pick and place equipment and stuff like that. So yeah, that's not going to work, but I'm hoping to move soon enough. We'll see though. It kind of depends on how my business does in this tariff environment, which yeah, we'll have to see. But yeah, there will be more videos in this series, so stay tuned for that. And that's it for this video. I hope you enjoyed this video. If you did, please leave a like down below, and thanks for watching.